So suppose you want to derive the following formula. Phi implies phi and phi. This is a very simple formula. And one way to do it is to notice that you have an antecedent here and you have a consequent here. Whenever you're trying to derive a formula that has the form of antecedent and consequent, you should assume the antecedent, in this case 5, and try to arrive at the consequent, and in this case is 5 and 5. So how do you do that? So let's start with assuming the antecedent. When we assume, we write the formula between square brackets. We call our assumption number 1, because that's the first thing we're assuming. We can, in fact, now what we want to do is that we want to arrive at the consequent phi and phi. So this is what we want to arrive at, phi and phi. This is our goal. Assume the antecedent and try to arrive at the consequent. How can we get from phi to phi and psi? Well, one way is that we assume phi twice. Now we assume phi, the same phi, so it's the same assumption, we call it number 1. We assume it twice. You can actually assume everything. So an important thing to keep in mind, you can assume anything you want. Okay, so we have phi and we have phi, our assumptions. Through the rule of conjunction introduction, we can put them together and we get phi and psi. So we're done. We have assumed the antecedent and we got the consequent. Now, how can we get, however, this in the form of an implication? There's one last step that we need to do. We need to use the rule of implication introduction. If we use this rule of implication introduction that is indexed to this assumption, so we write the little number 1 here, we can finally write phi implies phi and phi. And we can cancel this assumption up here, and once we do that, our derivation is done. It's important to keep in mind what the rule of implication introduction looks like. So the rule of implication introduction looks like this. So suppose that you are assuming some formula A, and then through some steps you arrive at the formula B. Now what you can do through the implication introduction is to write A implies B. So all you're doing, and then canceling your assumption here. So all you're doing here is that you take this assumption right here and you put it as the antecedent of your implication. And then you take what you got here as the consequent of your implication. So essentially the implication introduction makes this relationship between A and B, which in this case is vertical, into a horizontal relationship, but it's the same thing. And once you do that, you can cancel your assumption, and so you get A implies B. So whenever you use that rule, it's always important to index it to the number of the assumption that you're using. So if this you call assumption 1, then here you can write your number 1. And so you can see that this is the rule that we use in the derivation up here, because we had our assumption that we call number one. We got to this point phi and psi with our formula, and then we could apply implication introduction and cancel our assumption and get phi implies phi and psi. And so this completes our proof.